It's the first in, the last out, and never backs down. Built to lift, built to endure, and built to win. This is the CH-47 Chinook. Designed during the Cold War, then refined over decades of combat, and still flying to the front line today, the Chinook is one of the most battle-proven aircraft in history. In this video, we're breaking down the engineering, the evolution, the missions, and the stories behind one of the most iconic helicopters ever built. The Chinook's story begins late in the 1950s when the US Army identified a critical gap in its aviation capability. The current heavy lift helicopter, the aging piston-powered CH-47 Mojave, was underpowered, bulky, and had limited range. What the Army needed was something stronger, faster, and more reliable. That task fell to Vertol Aircraft Corporation, a company that was already experimenting with tandem rotor helicopters. But Vertol's time working on the Chinook was short-lived, because a year later, Boeing acquired the company. Along with the acquisition came the prototype YHC-1B that would later become the CH-47 and took to the skies for the first time shortly after. By 1962, it had officially entered service with the US Army as the CH-47A Chinook. From the beginning, the Chinook was built around a powerful idea: maximize lift, simplified control, and the ability to load and unload via a ramp at the back of the aircraft. Its unique tandem rotor design eliminated the need for a tail rotor, providing exceptional stability and allowing for full usage of the fuselage for cargo. For those of you who don't know, the tail rotor on a normal helicopter is there to counteract the torque from the main rotor. Without it, the helicopter would simply spin out of control. The Chinook's equal-sized rotors spin in opposite directions at the exact same speed, canceling out the torque from each other, making it an extremely stable platform. As the Vietnam War escalated, the CH-47A was quickly pushed into service. It became a game changer. In the dense jungles and mountainous terrain of Southeast Asia, Chinooks proved invaluable. Not only for transporting troops and equipment, but also for rescuing other downed aircraft. By the end of the war, the Chinook had recovered over 11,500 aircraft, valued at more than $3 billion. The Chinook has evolved over the years through various upgrades. The CH-47B came a few years after the A model in 1966, the C model in 1967, and the D model was introduced in 1982 with the biggest upgrades to that point. In 1988, the MH-47D was the first version specifically for special operations, followed by the upgraded MH-47E in 1995. The MH version was again upgraded in 2004 and included advanced avionics and a forward-looking infrared or FLIR system. This was known as the MH-47G Block II. The next upgrade on the standard Army version didn't come until 2007, which modernized the aircraft, and this is the one that we mostly see today. And finally, the newest and most advanced version is the MH-47G Block II. If you want to learn more about each of these variants, check out the longer, more in-depth version of this video on my Patreon. There's a link in the description below. Alright, let's dive into the different variants. The Chinook story begins with the CH-47A, first introduced in 1962 as a revolutionary twin-rotor heavy-lift helicopter. Powered by two Lycoming T55L5 engines producing 2,200 shaft horsepower each, it gave the US Army unprecedented vertical lift capability. Its tandem rotor design eliminated the need for a tail rotor and allowed for a spacious cargo hold area. While groundbreaking, the A model was limited by relatively low power output and basic avionics, making it suitable mainly for logistical support in Vietnam. But it laid the foundation for everything to come. Responding to the demands of combat operations, the CH-47B introduced several aerodynamic refinements and most notably, more powerful Lycoming T55L7C engines delivering 2,850 shaft power each. The B model also featured shorter rotor blades with wider tips and a redesigned pylon for improved lift and stability. Though it was only in service for a short time, it served as a testbed for advancements that would carry over into future models. The CH-47C was a major step forward in payload and performance. It received significantly upgraded T55L11C engines pushing out 3,750 shaft horsepower each. It also received a reinforced transmission system and improved fuel capacity. This model could haul heavier loads including artillery and vehicles and operate in more challenging terrain. Later blocks of the C model also added improved avionics and reliability upgrades, helping it serve into the 1980s, especially in the National Guard and Reserve units. Then came the CH-47D, an absolute game changer. Fielded in the early 1980s, it wasn't just an upgrade, it was a nearly complete rebuild. The D model introduced composite rotor blades, triple cargo hooks to help distribute loads, advanced hydraulic systems, and a modernized flight control system. It also came equipped with more powerful T55GA714A engines, producing 4,733 shaft horsepower each. The cargo hold was also widened, avionics were modernized, and onboard diagnostics improved maintenance efficiency. The CH-47D became the backbone of Army aviation for decades, proving itself from the deserts of Iraq to the mountains of Afghanistan. The MH-47D was the first dedicated Special Operations Chinook built for the 160th Special Operations Aviation Regiment, or SOAR, also known as the Night Stalkers. These were converted from existing CH-47C and D airframes but heavily modified to meet the demands of covert missions. Key features included aerial refueling probe allowing for extended range, long-duration missions behind enemy lines, forward-looking infrared or FLIR systems for night vision and target identification, fast rope and rappelling systems for rapid troop insertion and extraction, and upgraded communications and navigation systems for precision in low visibility and GPS-denied environments. While cutting edge for its time, the MH-47D lacked terrain-following radar and some of the more advanced systems that would later come. It laid the groundwork for all Special Operations Chinooks that followed, but was eventually phased out in favor of more capable platforms. One of those platforms was the MH-47E, introduced in 1995. Building on the D model, the MH-47E was a purpose-built special operations aircraft from the ground up, not just a modified airframe. It featured significant upgrades in avionics, survivability, and mission flexibility. Key improvements included terrain following and terrain avoidance radar, enabling low-level flight in total darkness or poor weather, ideal for nap-of-the-earth flying. Extended range fuel tanks and more robust aerial refueling capability. Enhanced defensive systems including radar warning receivers and IR countermeasures. A mission management system integrated with digital mapping and flight planning. And finally, more powerful T55GA714A engines for improved lift and performance at high altitudes. The E model allowed 1/60th SOAR crews to penetrate deeper, fly lower, and operate stealthier than ever before. It was the ultimate special operations platform of the 90s and early 2000s. In 2004, the MH-47G Block I was the next evolution, combining the best elements of the MH-47E with modern digital systems. Unlike earlier upgrades, Block I Chinooks were largely built or remanufactured from scratch, using improved CH-47F production standards as a base. Notable enhancements include Common Avionics Architecture System, a fully digital glass cockpit used across special operations aircraft for interpretability, a fully integrated mission management system including real-time data sharing, GPS, INS, and encrypted communications. upgraded defensive suites including missile warning systems with chaff and flare dispensers, advanced aircraft survivability equipment, and reduced acoustic signature for stealth operations. And finally, they improved the rotor system and drivetrain reliability. The Block I version was a significant leap in terms of automation, situational awareness, and networked warfare, perfect for modern joint operations. Next, the CH-47F ushered the Chinook into the digital age. Introduced in the mid-2000s, it featured a monolithic machined airframe that reduced vibration and increased durability. The cockpit was completely overhauled with the Common Avionics Architecture System, a glass cockpit suite with integrated mission management tools. The engines remained the same, but the drivetrain and transmission were refined for better power efficiency. Together, these upgrades boosted lift capacity, situational awareness, and flight reliability in demanding conditions. Later variants like the CH-47F Block II use a monolithic airframe, a single-piece structure that adds massive strength while minimizing maintenance needs. The Block II version of the F model also introduced advanced composite rotor blades that are lighter, quieter, and more efficient, helping increase lift capacity by over 1,500 pounds compared to the earlier versions. And then finally, the MH-47G Block II is the latest and most advanced Chinook ever built, designed to meet the increasing demands of future special operations forces. Block II includes newly manufactured aircraft and upgraded Block I airframes. These MH-47 upgrades include advanced Chinook rotor blades made from high-tech composites delivering significantly more lift, a strengthened fuselage and improved fuel system increasing range, durability, and internal volume, a higher payload capacity supporting more gear, troops, or specialized equipment, and redesigned electrical and hydraulic systems to improve reliability, simplify maintenance, and increase compatibility with future systems, including next-gen sensors and mission packages. The Block II aims to extend the Chinook's relevance well into the 2060s, ensuring it can operate in contested environments and carry out high-risk, high-reward missions with total reliability. For over 60 years, the Chinook has been upgraded, refined, and battle-tested. And yet, its core design remains largely unchanged, a testament to just how far ahead of its time it was when it first flew. At a glance, the CH-47 Chinook is unmistakable. Long and lean with those massive tandem rotors spinning in perfect counter-rotation. But under that distinctive profile lies one of the most technically advanced and proven airframes in military aviation history. So let's break it down. The Chinook is a giant in the rotorcraft world. It stretches 98 feet 10 inches from rotor tip to rotor tip. The fuselage itself measures about 51 feet long, and it stands at 18 feet 11 inches tall. Its massive rotors span 60 feet in diameter, positioned front and rear to balance the lift and eliminate the need for a tail rotor. Connecting those two rotors via the transmission is a massive drive shaft that runs from the back to the front, ensuring they spin at the exact same speed to keep it stable and controlled. That tandem configuration is what gives the Chinook its superior lifting capability and compact ground footprint, which is essential in tight landing zones. When it was introduced, each engine produced about 2,200 shaft horsepower, but that was more than doubled in the D model to 4,733 shaft horsepower, thanks to the two Honeywell T55 GA714A engines. There are even some versions today that produce more than 5,000 horsepower, and the newest engine is said to produce more than 6,000. That power translates into a top speed of 170 knots, making it one of the fastest helicopters in the US inventory. With a max gross weight of 54,000 pounds, the Chinook can carry up to 24,000 pounds internally or sling load nearly 26,000 pounds externally using the triple hook system. And those hooks can operate independently or in tandem, which is ideal for moving artillery, vehicles, or emergency supplies in a single lift. This is one of the reasons we've started seeing them used more and more for fighting wildfires. The ability to deliver thousands of gallons of water in an area that tankers can't go is a huge advantage. The CH-47 has a range of 400 nautical miles on internal fuel, and even farther with auxiliary fuel tanks. In the field, that means a mission radius of more than 165 nautical miles with enough fuel to get in, deliver, and get out safely. And the Chinook can fly surprisingly high. Its service ceiling is over 20,000 feet, allowing it to operate in extreme high altitude environments where other helicopters simply can't go. We've even seen it used to make high altitude rescues on Mount Rainier. Modern Chinooks like the CH-47F come equipped with advanced digital cockpits called the Common Avionics Architecture System, or CAAS. It features large, multi-function displays, secure communications, satellite navigation, and mission planning tools all integrated into a single interface. For stability and safety, especially in degraded visual environments like dust or snow, the Chinook uses the Digital Automatic Flight Control System. This fly-by-wire system dramatically reduces pilot workload, especially during hovering, sling load missions, and tight mountain landings. The Chinook's airframe is a blend of traditional aluminum alloys and composite materials that help reduce vibration and improve durability. The Special Operations MH-47G features a mid-air refueling probe to help extend their reach. This is usually done behind a C-130 using a drogue system. When you're approaching a helicopter on the ground, the safe areas are typically around the front and sides. But the Chinook is different. Its safe area is actually at the rear, which was done on purpose to allow it to be loaded from the back via the loading ramp with plenty of clearance. The ramp allows rapid drive-on, drive-off loading, perfect for vehicles, small artillery, or casualty evacuation litters. The interior can be configured to hold up to 44 seated troops, 24 medical litters, or a combination of both, making it a flying utility platform for nearly any mission. With its wide fuselage, flat floor, and roller systems, the Chinook is optimized for loading under fire, at altitude, or on the move. There's a reason it's the backbone of rotary wing logistics for forces around the world. If there's one thing the Chinook doesn't do, it's sit still. From combat zones to disaster zones, mountaintops to oceans, the CH-47's mission set is as versatile as any platform in the skies today. When ground troops need gear fast, ammo, food, water, weapons, the Chinook delivers. Like I mentioned, it can carry up to 24,000 pounds internally, or sling load nearly 26,000 pounds. That means it can carry things like a howitzer, a containerized water system, or even a damaged Black Hawk being pulled out of a fight. And thanks to the triple hook system, the loads don't all have to be in one piece. Multiple sling points let crews distribute weight and deliver to different locations all in one flight. During operations in Iraq and Afghanistan, Chinooks were often the only reliable way to resupply remote outposts, especially those in mountainous terrain and under threat of ambush. Their speed, range, and lift capacity made them perfect for sustaining forward operating bases and moving heavy equipment where trucks simply couldn't go. It's been called the flying pickup truck of the military, and for good reason. Outside of combat, the Chinook has become a key lifeline for disaster relief, military aid, and these days you'll see them dropping water on wildfires. It's been used to deliver things like clean water, field hospitals, and emergency shelters into devastated zones in places like Nepal, New Orleans, and even in Europe after floods and fires. And here in the US, natural resource divisions have started incorporating firefighting versions of the Chinook to help fight wildfires. For the most part, you see them in the US and Canada, but Billings Flying Service has also contracted 3 of their Chinooks with agencies in South Korea during their fire season. Thanks to their massive capacity, they can be equipped with water buckets or internal tanks, dropping thousands of gallons of water all at once right on top of the fire. The Chinook isn't just military gear, it's a tool for saving lives. Then there's the most advanced version, the MH-47G, the blacked out, sensor-laden special ops variant used by the 160th SOAR, aka the Night Stalkers. This version is equipped for stealthy insertions and extractions behind enemy lines, fast rope deployments, low-level nap-of-the-earth flying, aerial refueling. These birds operate where others simply can't. On this model, you'll notice the giant probe sticking out of the front. And a lot of people ask, is that a cannon or a gun? The simple answer is no. It's actually the aerial refueling probe that allows them to refuel the helicopter mid-flight, substantially extending their range for critical missions. The MH-47 is what was used to extract the operators whose helicopter went down during the Bin Laden raid. They flew in under cover of darkness, evading the Pakistanis and getting our troops out safely. When a high-stakes mission demands precision, power, and flexibility, there's a good chance a Chinook from the Night Stalkers is involved. One of the Chinook's most underappreciated capabilities is its ability to perform pinnacle landings, touching down on tight, elevated terrain like mountain ridges or rooftop helipads with just its rear wheels and the ramp. Even more impressive, it can do water landings. With proper procedures, Chinook crews can gently settle the aircraft onto the surface of a lake or ocean. Engines still running, rotors still spinning, while passengers or cargo are offloaded via boat or ramp. Imagine the level of training and engineering it takes to land a 50,000-pound machine on a mountaintop, or on the open sea, and then take off again. Behind every Chinook mission, whether it's a high-stakes combat insertion or a wildfire drop, is a tight-knit crew of 3 making it all happen. At minimum, the Chinook flies with a pilot, co-pilot, and flight engineer, or crew chief. The pilot and co-pilot handle navigation, flight controls, and systems management, often coordinating complex missions in dynamic environments. The flight engineer or crew chief are the system watchdogs, responsible for monitoring mechanical health, load operations, sling load management, and even manning the guns if needed. On certain missions like special operations or high-risk insertions, a 4th crew member might be added for extra support and situational awareness. Flying a Chinook isn't just a matter of clocking flight hours, it requires an intensive multi-phase training program. Crews start at the US Army Flight School, learning the fundamentals on helicopters like the TH-67, Bell 206, or the UH-72 Lakota. After graduation, pilots are assigned to a platform, and that's when they dive into the Chinook-specific training. This includes aircraft systems and emergency procedures, tandem rotor aerodynamics, which are very different than other helicopters, heavy lift dynamics and multi-hook sling load operations, and ramp loading and cargo balance for safe flight. To fly in the real world, though, they need far more than classroom time. That's where the specialized training comes in. Night vision goggle qualifications for nighttime insertions and low-light operations, dust landing procedures or brownout-whiteout recovery to operate safely in desert or snow-covered zones. If you've ever seen one of these things land, you know just how much dust they kick up. And then finally, training for the different types of landing zones, pinnacle landings, confined areas, and water landings for amphibious operations. And for MH-47G crews and special operations units, the training pipeline is even longer and more selective, covering fast roping, infiltration and exfiltration, aerial refueling, and tactical low-level flying. These pilots are the tip of the spear, the best of the best. When it comes to heavy lift helicopters, the CH-47 Chinook sits in a class all its own. But how does it stack up against other giants in the sky? Let's start with Russia's Mi-26, a massive 8-bladed heavy lifter. On paper, it wins the brute strength contest. It's the largest and most powerful helicopter ever built, capable of lifting up to 44,000 pounds internally. But the Chinook trades raw muscle for agility, reliability, and operational flexibility. The Mi-26 needs more ground support and a larger landing zone. It's heavier, slower to deploy, and harder to maintain. The Chinook, by contrast, is nimble, able to land on narrow ridge lines, hover in tight terrain, and reverse out of a hot zone if needed. In combat logistics, versatility often beats size, and that's where the Chinook excels. Another heavy lift helicopter in the US inventory is the Sikorsky CH-53. It can carry up to 36,000 pounds, more than the Chinook, and it uses an advanced fly-by-wire control system, composite rotor blades, and cutting-edge avionics. But while the King Stallion is the future of marine aviation, the Chinook is the combat veteran, with over 60 years of global operations, from Vietnam jungles to Afghan mountains. Plus, the Chinook is operated by the US Army and the CH-53 by the Marines. There are also a handful of civilian heavy lifters like the Erickson S-64 Sky Crane, known for firefighting and construction. While impressive, they're mission specific, great at hauling external loads like buckets or lifting towers, but they don't offer the versatility of an internal load like the Chinook. And even though the Sky Crane is specific for external loads, the Chinook is still able to carry 6,000 pounds more. The Chinook can do it all, sling load heavy gear, and thanks to the internal capacity, it can carry troops, drop relief supplies, and extract teams. So in terms of multi-role adaptability, the Chinook holds a rare edge, even among its larger, newer, or more specialized peers. Now with all that engineering and capability, what does it cost? Well, a brand new CH-47F rings in at about $32 million per unit. But the price doesn't stop at the factory. With fuel, maintenance, spare parts, and upgrades, operating costs are high. Exact hourly costs vary by mission, but estimates place it well into the tens of thousands of dollars per flight hour, especially for high-tempo combat or special operations use. For a little bit of insight, many contractors for wildfire operations will charge $10,000 to $20,000 per flight hour, and $30,000 per day when it's not flying. That's $30,000 to just sit on the tarmac for a day. Why is it so expensive to operate? Well, this is a massive, complex machine with twin engines, advanced avionics, and a complicated rotor system. Every component, from the composite rotor blades to the hydraulic systems, needs regular inspection, maintenance, or replacement. Primary maintenance occurs every 60 flight hours. Deeper services happen every 600 hours, and parts like rotor blades and transmissions are life limited, meaning they need to be swapped out after a certain number of hours no matter what. But here's the thing, it's all worth it, because when you need to move more than 20,000 pounds of cargo into a war zone or sling a howitzer onto a remote ridge, there's nothing else quite like it. But it's not just the US that operates the Chinook. The US Army is the largest operator by far, with hundreds of airframes spread across active duty, National Guard, and reserve units. But it doesn't stop there. More than 20 other countries fly the Chinook as well, including Canada, Australia, United Kingdom, Germany, Japan, South Korea, Italy, Netherlands, United Arab Emirates, Spain, Greece, Turkey, and India. From NATO to Asia Pacific to the Middle East, it's trusted around the world. Why? Because it works. It works in the snow, the sand, the jungle, or the mountains. No matter where it is, the Chinook gets the job done. The CH-47 Chinook is more than just a helicopter. It's a lifeline, a workhorse, a legend. From the jungles of Vietnam to the mountains of Afghanistan, and from wildfire zones to humanitarian crises, it's been there, lifting, flying, and doing the impossible for over 60 years. And with modern upgrades and a bright future still ahead, the Chinook isn't done yet. If you enjoyed this breakdown and want an even deeper dive into the history, engineering, and untold stories behind aircraft like the Chinook, I've got an extended cut over on my Patreon. You'll also get access to bonus behind-the-scenes content, exclusive footage, and more. Plus, you'll get early access to all my new videos before they're released on YouTube. You can find that at the link in the description. And if you're into aircraft, photography, or just fun adventures, be sure to subscribe, drop a like, and tell me in the comments, what's your favorite thing about the Chinook? Thanks for watching. I'll see you guys in the next one.